Okay, 7-3. Moving on. Okay, now we're going to use multiplication and division. Oop. Okay, so we added and subtracted. Now we're going to multiply and divide. Again, just like before, we have inverse operations. Okay, it was no different when we added and subtracted. If you were given a multiplication equation in this case, you're going to do what to solve it? What's the opposite? You're going to divide. Okay, if given a division problem, you're going to multiply to solve it. Okay. We'll start off easy here. Okay, 81 is equal to 9R. Again, the first thing you're going to want to do is identify what kind of an equation it is. That would be a multiplication, so we're going to divide. Okay, now I'm going to show you a little shortcut. Okay, so we're trying to get the variable by itself, right? So what are we going to divide by? Just yell it out. What are we going to divide by? All right, we're going to divide by 9. What you do on one side, you got to do on the other. 9 divided by 9 is actually 1, and you get R. Okay, but again, we don't write the 1. I just wrote that there. I'm going to erase that. Okay, so we just get R because there's an imaginary 1 out there. We already know that. Okay, and 81 divided by 9 is 9. All right, multiplication, pretty simple. 81 is equal to 9 times 9. We plug in our solution. 81 is equal to 81. And we know we did it right because our scale is balanced. Right? Multiplication, pretty simple. Okay, what if we have something that looks like this? Because there's many multiple forms of multiplication that they could give you, at least what it looks like, right? What's a little different here than is on most of them? What do they have, Michael? Okay, they have the raised dot here, right? Now, sometimes they'll do that, sometimes they won't, but traditionally, this should look like what? Go ahead. Yeah, this should look like 3p, right? But again, don't get confused here because I'm going to show you a couple different ways that they can express multiplication. You just got to go with what you know, right? Okay, so it's multiplication. So we want to get the variable by itself. So we use our inverse operation, which is multiplication problem. So we're going to divide by 3 the number on the side of the variable, right? So over here we get P is equal to 6. As you can see, multiplication is pretty easy. So if we plug in our solution for P, which was 6, again, we get 18 is equal to 18. All right, you good with the multiplication? Yeah, that's pretty simple. All right, moving on to division. So if we have A divided by 8 is equal to 6. All right, this one might be a little bit trickier. We know that it's a division equation, so what are we going to multiply by? Be careful. What do you think? Any takers? How do we get A by itself? How do we, because if we got to get A by itself, that means we got to do something with the 8. Grayson? By? What are we multiplying the 8 by? How do you do that? So here's what you do mathematically. Any whole number is over 1, right? So we can't just multiply it by 8. Remember, there is an imaginary 1 here. So we have to take the reciprocal of 8. Several years ago, this was an error question. And everybody said multiply by 8. And got it wrong. You're multiplying by the reciprocal of 8. Why? Because now you have fractions, yes? And when you cross reduce, now you're just left with your variable. The key here is you're multiplying by the reciprocal. So if we went and checked it just to make sure, so what's our check? Our answer is 48 divided by 8 is equal to 6. 48, that would be 6 is equal to 6. Seven is equal to V divided by 6. Again, we want to multiply by the reciprocal. And you can even put parentheses around these, whatever you want to do. And when you go and you do the math, cross reduce, that gets left with V. On the left side, you multiply straight across, you get 6 times 7 is 42 over 1, which is just 42. So again, if we go to check it, 7 is equal to 42 divided by 6. 7 is equal to 7. We're good to go. All right, when they're in fraction form, I would say that they're pretty easy. Okay, you're multiplying by the reciprocal of the bottom number. What happens if we get something that looks like this? What happens if we get something horizontal? Well, there's two options actually. You can solve it this way. It just probably will look a little bit funny. If you solved it keeping it this way, you would probably do it like this, like we did with addition and subtraction, which does look kind of funny, right? Obviously, those cancel out, and you're left with 20. So if we plug that in, yeah, we would be right. So your choice whether you want to do it that way, that's fine. Or, right, we could rearrange it the fraction way. Knowing since the beginning of the year that we talked about that the number behind the sign is called the what? Number behind the sign is called the coefficient? No. No. What division term is the number behind the sign called? The divisor. 7 months in and we forgot that. That's not good. Okay, so here you could do it how you were just taught, right? Those cancel out and we get z is equal to 20. And our check still works. So far, so good. All right. So now we got a picture. Now they don't give you the equation. You now have to come up with the equation and solve it. This is why we did lesson 7.1, writing equations, so you can write them. Okay, 7.2 was solving them, addition and subtraction, and 7.3 today is solving them, multiplication and division. All right, so how can we solve for x? Well, the first thing is we have to come up with an equation. Yes, I know probably all of you are thinking, well, the answer is 4, Mr. Fisher. I get it. But unfortunately, you got to write an equation and then solve it. Anybody have an equation? I think you mean this. Yes, 6x is equal to 24. That is correct. It's a multiplication equation. How do you know that you should multiply? Because you're finding the area. That's why. You learned that back in elementary school. Yes, you'll have to come up with the equation. Okay, since we have a multiplication equation, we are going to divide to solve it. And now we get our x is equal to 4. So when we go to check it, right, we get 6 parentheses 4 is equal to 24. 24 is equal to 24. All right, next shape. Is our dreaded triangle. Area of the triangle is 28 units squared. You know the base is 8, and we would like to find out the height. What do we do? Michael? 8x divided by 2 is equal to 28. Is that what you, that's what you said, I believe, right? Yes? Okay. How many of you like Michael's equation? Yeah, he's right. He's absolutely right. Okay, this goes back to the formulas, lesson 1-5. Okay, and chapter 5 as well. Okay, now this is where you may not be used to this, maybe, I don't know. Okay, 8x divided by 2. Can we do that mathematically? Can we reduce it, is what I'm asking. Yeah, what do you want to reduce it to? Can we or can we not? No. Yes or no? Does 2 go into 8? Yeah, how many times? 4x. Sure, you can reduce it. It's a fraction, isn't it? Can you reduce fractions? Yeah. Okay, and what reason I asked that, I know the x is throwing you off. Well, the x always travels with your answer here. Now we have a multiplication equation, which means that we're going to divide. How many 4s go into 28? That would be 7. Well, let's check. Excuse me, let's check to see if our height, 8 times 7 divided by 2 is equal to 28. 56 divided by 2 is equal to 28. 2 goes into 56 28 times. That means the height, oops, I messed that up already. The height of our triangle is 7. All right, everybody good with the shapes? One last thing I want to show you. I don't know if you'll run across it today, but at some point we are. All right. Might want to write this down. What is different about this one than any other one that we've ever done? Nobody sees anything that is drastically different than any equation we've done in the last 3 days. Ready? What does that mean in English? Okay. Michael? Okay. X is negative here. Your variables have always been positive up to this point, yes? Okay, listen carefully. In the world of algebra, guess what you can't have? A negative variable. Okay. So, in the event that you would get a negative variable, you have to pretty much do one extra step here. Because normally we would start by subtracting 45. You agree? Right? That's what we would normally do. Okay, but since our variable is negative, we have to get it to be positive. You have to get your variable to be positive. There's no questions. So now you had to move the variable first to get it to be positive before you could even think about starting to solve your equation. Now, instead of your thought process of subtracting 45, you now are subtracting 31. Okay, so if your variable is negative, you have one extra step. You always need to get that to be positive first. Does it make sense? You got to recognize that. Does everybody understand that let me rewrite this again. Does everybody understand how this is that's negative? In the world of mathematics, you should have learned in elementary school, right? Didn't you turn a subtraction problem into an addition one, right? I do believe. Okay, and if you do that, this is what it looks like mathematically. If you need to write that down, you might want to write that down. Some people can't go from here to there. Because when I say this variable is negative, some of you look at me like, what? That's a subtraction sign. Yes, it is. You're right. But it's also negative. Now, I don't know if you're going to get any of those today, but they are coming down the road. I just wanted to introduce that to you today. Okay, everybody good? You know the steps that you need to show. All right, you do have an Ed puzzle. Some of you still might want to look. You haven't done yours from before. Okay, today we're going to do 1 through 29, the odds in 7-3. And again, I can only encourage you to show all of your steps because that's how it's going to be graded on the quiz.